All right, everybody, welcome back. We are looking at the last topic that we're going to study here on radicals, and this is culminating in radical equations. So we've looked a lot about how we manipulate, add, subtract, multiply, divide, rewrite radical expressions, and now we're going to solve radical equations. So obviously, a radical equation is any equation that has some sort of radical on one or both sides of that equation. Now, we have to remember that there are certain restrictions that can happen here. So whenever we have a radical equation or expression and there's a variable that's in the radicand, that if it's an even index on the radicand, then it cannot, the radicand can't be negative. So in this case here, the square root of 3x equals 9. We're not going to solve that right yet, but just to point out that we know that the restriction there is that 3x must be greater than or equal to 0, which is basically just saying that the radicand cannot be negative. And so, of course, we can divide both sides by 3 to say essentially, okay, well, x must be greater than or equal to 0. X itself cannot be negative, all right? If we have something like square root of 2x plus 3 equals x, there's no restrictions on the right side of the equation, but on the left side here, I know that 2x plus 3 must be greater than or equal to 0. And now I solve. So I move 3 to the other side. 2x must be greater than or equal to negative 3. And then divide by 2. So x must be greater than or equal to negative 3 halves. And there is my restriction. So pretty straightforward. Essentially what we're doing is we're just going to take whatever the radicand is and say this thing must be greater than or equal to 0. Now this one's a little bit of a twist because I've got a radical as well as a rational equation. And so my one restriction says that 5 minus x must be greater than or equal to 0. That's the restriction for it being a radical. And then I could sort of solve that and move x to the side, and I would get 5 must be greater than or equal to x, or x must be less than or equal to 5. So that's fine. Just recognize that there's another restriction here because of the fact that it is a rational. So the fact that it's a rational means I can't divide by 0. So essentially I've got my 5 minus x cannot equal 0. And if I move x to the other side, I get x cannot equal 5. So I've sort of got two restrictions there. And whenever you have that situation, you just have to make sure that both of the restrictions kind of jive, that you're not either saying something extra that you don't need to say or that they don't conflict with each other. And so here, x must be less than or equal to 5, but I also know x can't equal 5. So that just means that x must be less than 5. And that is my one way of stating the restriction. So we're going to solve some radical equations. And when we do this, there are some extra steps involved that we didn't see when we were doing other kinds of equations, okay? Because that's all because of something called extraneous solutions, which is basically, I might do all the algebra, I might do it entirely correctly, and then I might get answers, and those answers, when I put them back in the original equation, actually don't make sense. They don't work. So we're going to have to do an extra step of verifying. The steps that we are going to follow is, number one, we're going to state our restrictions, because that's fun. And then two, if we have a radical, we need to isolate the radical. So instead of isolating for x or the variable, we're going to isolate the entire radical, whatever it is. And once we have the radical isolated on either side of the equation, we're going to eliminate that radical. So for example, if you're taking the square root, you could square it. If you're taking the cube root, you could cube it, or whatever you need to do to get rid of or eliminate the radical sign. And then once we've done that, then we can solve. So now we can just solve for whatever variable we're interested in. And then that last step, which is so easy to forget, is we have to verify. So whatever answers we get, we always have to substitute them back into the original equation and see if they actually jive, if it actually makes any sense. So I've got one here, 5 plus root 2x minus 1 equals 12. So I'm going to solve that. First thing I do is I'm going to state my restrictions. So I've got 2x minus 1 must be greater than or equal to 0. That means 2x must be greater than or equal to 1, which means x must be greater than or equal to 1/2. So there's my restriction. And now I can go ahead and solve. So I will, on each side of the equation, I'm just going to subtract 5 from each side. So I have the square root of 2x minus 1 equals 7. And now the way to get rid of that square root sign is to do the opposite. Just like to get rid of a division, you multiply. To get rid of subtraction, you add. So I'm going to square both sides of this equation. And that eliminates my radical sign. So I get 2x minus 1 equals 49. And now I just solve, straightforward. So I'm going to add 1 to both sides. So 2x equals 50. And then just divide by 2, and I get x equals 25. Now, that seems to work just fine, but like I said, I always have to go back and verify. So I'm going to go back to my original equation, and I'm going to verify x equal to 25. Note that it doesn't conflict with my restriction, so that's a good sign. And the first point, but I still need to put it back in the original equation. So 5 plus the square root of 2 times 25 minus 1 equals 12. Is that true? Well, this is like 5 plus 2 times 25 minus 1, that's 49 equals 12. Yeah, 5 plus 7, that equals 12. So I'm verified, so now I know that this answer is good. I can keep it. If that equation didn't work out, then I would just have to reject either one or both of my answers, whichever ones don't work. So we'll see that sometimes we might actually, in this case, there was only one solution, and we might get multiples. So let's try this next one here. First step is I need to state my restrictions. So my radical sign there, I've got 5 minus n must be greater than or equal to 0. So I'm just going to move n to the other side, and I get 5 must be greater than or equal to n, which is the same as saying n must be less than or equal to 5. Remember that if you want to flip your equation, your inequality around, you have to flip the sign to go with it. So normally what I would do when I'm solving an equation is I would isolate the variable, but that's not going to work in this case. I need to isolate the radical. So even though I've got n here, and then I've got an n inside my radical sign, I'm actually going to move that whole radical sign over to the other side of the equation because I need it on its own. So I'm going to add the square root of 5 minus n to both sides of my equation. Okay, and I'm moving that over because it's got a negative sign and I just prefer not to have it. So in addition to that, I'm also going to add 7 to both sides of the equation and see that those cancel out. So I'm going to get 9. n plus 7 equals the square root of 5 minus n. All right, so my radical is isolated. This is what I've always wanted in life. And so now I can square both sides of the equation. You have to be careful though, because when we say square, you have to square everything. So n plus 7 is a binomial. When I square that, that means that's going to expand out. That's going to be a binomial expansion, n plus 7 times n plus 7. So I have to expand that whole thing out like we've done before. Whereas on the other side of the equation here, this is just going to become 5 minus n. So the square root sign just disappears. If I FOIL out n plus 7 times n plus 7, I get n squared plus 14n plus 49. And I'm just kind of skipping a step with the foiling because at this point we should be pretty comfortable with how that goes. And now I can start to solve. So I'm gonna, I can collect like terms. So add n to both sides, subtract 5 from both sides, and I get n squared plus 15n plus 44 equals 0. Now, I've got a quadratic and it's set to 0, so I could solve it a bunch of ways. I'm going to try and factor it first just to see if I can. Looking for two numbers that add up to 15 and those same two numbers that multiply to 44. And they're both positive, so I guess 11 and 4 would do the trick. So I've got n plus 11 times n plus 4 equals 0. And so when I solve this, I get n equals -4 and n equals -11. Now, I need to point out here that n, in this case, both of those seem to fit with my restrictions. Those don't seem to be an issue over there, but we need to see what else can happen. Is this actually verifiable? So I'm going to verify both of those answers. So let's do this over here. Verify, not x, n equal to -4. I'm just going to put that back in the original equation, see what happens. So this would be like negative 4 minus the square root of 5 minus negative 4. Careful with my minus signs, holy smokes, equals negative 7. So does that work? Well, this is like minus 4 minus the square root of 9 equals negative 7. The square root of 9 is 3, so this is like minus 4 minus 3 equals negative 7, and that makes sense. So that one is verified. Negative 4 works. Let's just try, n equal to negative 11, see what happens. So I've got negative 11 minus the square root of 5 minus negative 11 is equal to negative 7. So negative 11 minus the square root of 16 equal to negative 7. The square root of 16 is 4. Negative 15 equals negative 7. Yeah, no, I don't think so. So I have to go back to my original answers here. I need to reject this one. N equal to negative 11 just doesn't work, whereas n equal to negative 4 is a correct answer. Okay, that's it for solving radical equations.